See a red light, I'm rolling.
Hi, I'm Rich with insideHPC. We're here at ISE 2019 in Frankfurt, Germany. And I'm here with some folks from ParTec and the Jülich Supercomputing Centre. We're going to get an update on modular supercomputing. So, Thomas, why don't we start with you? Can you remind us what is modular approach to HPC and what's happened since we last talked?
So, my name is Thomas Lippert. I'm the director of the Jülich Supercomputing Centre. So what is modularity? So it's not just an approach to HPC. I would even say that modularity is an organizational principle that will allow us to build the data center of the future. So why? Modularity is short for composable systems, so that we can have a disaggregated bunch of resources. And then we have a software layer on this disaggregated bunch of resources. Take GPUs, take CPUs, take FPGAs, take storage media, and then compose them to build, so to say, the supercomputer that you would want to have. Yeah. So, and you can get it even on a dynamical manner, so that finally you are able to have the system that you would like to have for your science, for your simulation, for your data analysis. In this sense, you would not be able to distinguish between a standard data center, let's say, build up, and a supercomputer, because the only thing that is required is to have a highly scalable element that finally is, so to say, the one that constitutes a supercomputer.
Yeah. So what's happened this past year?
So in the past year, we have exercised the modularity in systems that we had built the year before. So one is a Jureka system in Jülich. Then we have started to build a new one that is Jules. You know, the Jules was inaugurated in the summer of 2018, and now we are in the design phase that the Jules system gets its bigger part. So we hope, it's not yet announced, but I can say it here, that the Jules booster will be announced soon to be coming next year, and it will be well beyond the factor of 7 to 8 larger than the present module that we have. But it will be the highly scalable one based on GPUs, and finally be able to interact with the cluster.
Okay, so a lot of progress in the past year. Congratulations on that.
I would say so.
Yeah. Okay, well, let's move on, because I wanted to find, what has the take-up been on this modular approach to supercomputing internationally?
Well, Rich, that's a very interesting question, and I'm happy for the opportunity to be able to answer on that question. Just to remind us, we started in 2010 about with Thomas to reduce to practice the modularity, his idea that he has been carrying at that time already for years. And the idea was that, in principle, the theory of making nodes fatter and fatter wouldn't work. The more complex those machines, the bigger those machines would be to be constructed, it wouldn't work anymore. They would kind of extinguish themselves in the complexity of these nodes. And the idea was, as Thomas has just described, to disintegrate hardware or software or both, the decisive elements, CPU and GPU, to put it in short, and then go forward from there and build machines which separate those physically and or per software, as I said, functionally, and do this. What has happened internationally is an interesting development, which I frankly have seen many times with new technologies, also in totally different areas of technology. What is that? In the first phase, you find nothing but resistance. A strange idea, who would do this? And we talked to companies not only in Europe, in Germany, but also abroad, and that means, of course, United States. And the response was, nothing we are really interested in. Sounds quite interesting, but it's not for us. We have totally different approaches, especially to pre-Exascale and Exascale. And that was quite of disappointment for us. We thought the world will fly on to this modularity. That was then. But what we see now since about 1 year or 2 years, and I have a few documents here in front of me, is that the world suddenly finds that an architecture, what they now call heterogeneous flexible architecture, as an example here for Tianhe 3 for China, how they would like to construct these machines. That what I see here clearly tells me that is the modularity Thomas has invented 10 years ago. And similar developments I see in the United States, as an example here, Gen Z. Of course, you would have to know more details about this, the functionality and how is the data flow organized. But we see disintegrated separate CPUs and GPUs, accelerators. And what is interesting, that is the interconnecting network between those separate, I would like to say, discrete elements almost. It reminds me to the infancy of semiconductors, when that was in the 60s. I was already alive there, when discrete elements were suddenly in the market, and we have discrete elements here as well, which have to be interconnected. And this network between those elements is decisive also to make them reconfigurable, to organize the elements so that the algorithm, the data to be computed, can best be handled by the most appropriate of those elements, CPUs or GPUs, or also other elements. So in a nutshell, we see a development also now in Europe, in the program of Euro HPC, that we see hosting sites which have been appointed as the best example for us, and we like it, of course, most, which is Luxembourg. Luxembourg has decided we build a supercomputer based on the modularity developed, invented, and also reduced to practice already in Jülich with the help of ParTec, and we're extremely proud of this. What we also see with great pleasure is that other hosting sites in Europe, which go into the 200 plus petaflop area, also seem to adopt the modularity that we like so much. And I wouldn't like to give names right now. This is a sensitive matter, because to put it to an end, the fact for me is we see the normal life cycle of an invention, a great invention, always, almost always, I dare to say, Rich, not good, not new, not necessary, no application for it. And then you see the transition period, and once it is in the brains of everybody and is used, then it was there, it's not inventive, we had it all the time. So that's where the phase we are currently in. Maybe that's it for now.
Okay, well, Hugo, in that context, can you tell me more about how this fits in with the Euro HPC efforts that are going on right now and the pre-Exascale systems we just heard about?
Well, Rich, what Bernhard said, the procurements we saw for the hosting site, for the pre-Exascale and the PetaScale hosting site, we see decisions in the application from the sites towards modularity. Bernhard mentioned Luxembourg. There are others in the pre-Exascale side as well, and also some candidates further in the PetaScale hosting side. So the very thrilling thing actually is that what started as an invention, what made it through deeper and deepest European projects, came into the production level at the Jülich Supercomputing Centre, and now it's spreading out through the Euro HPC procurement. And this is, of course, fantastic to hear, because from an idea via the prototype to a production level system, you don't see that too often. Yeah. And this is really the great story behind it. And it has the idea of having a very efficient way to combine different compute elements and to make it available on the fly in a dynamic way. And this is actually something the Euro HPC procurement showed. And all the candidates going in with modularity, they made it. They fulfilled the qualification, and they will have PetaScale next June, actually a year ago, when we sit here and will not only celebrate the Joules booster in Jülich, but also the PetaScale systems. But we will also see then in November next year at SC the 3 pre-Exascale hosting sites, where we also see modularity. So this is a very good news for us. And actually, after so many years of hard work, it's great.
Well, Thomas, question for you. I mean, what does this mean for end users, your customers, the scientists that use these machines to do research? What is this gonna? How will this benefit them?
It's of course the most important question. Why should we do it? I think that the only way to get a cost-effective, let's say, path to Exascale and beyond, and also to include new technology, means finally that you have to have a modular approach. Think of new future computing technology like quantum computers. How, by the way, would you integrate those machines into a workflow? There is only one way. The way is you have to have the machine in the workflow as a hardware system. Yeah? You will not distribute a quantum computing processor in 2 fat nodes. We know that it is not possible. There are just discrete elements. You might be able to have sort of emulated ones, but this is another issue. And maybe you might also have neuromorphic technology, which is also very closely coupled with the different compute elements that you have for that. So you will have one parallel neuromorphic machine, you have a quantum machine, and whatsoever comes, maybe a digital annealer, you will also not distribute. So these things finally have to be coupled by a modular way into your workflows, even into your programs that you want to run. So in this sense, of course, the user will profit because it's possible to use those machines then in a hybrid way, yeah, with HPC together. The other one is certainly that we believe designing the hardware according to the needs, yeah, and not just according to the fact that you want to replicate one and the same component ad infinitum, and you have to make it very expensive and whatsoever, because you have also to run a small program on it, and in an optimal manner it's just prohibitively costly. So on the other hand, if you can design your scalable part as slim and as, let's say, cost efficient as possible, and if you still are able to run those programs due to the modular approach, of course the user will benefit by the fact that there is much more compute time available than on those systems. So these are the 2 reasons. But I did not even mention now what I can say about data centers, as I started with that at the beginning. And here I believe if we want to think of how a future data center should look like, where finally also a supercomputer might be an element of it, it will be modular, nothing else.
Yeah, well, that's exciting. Well, what do you guys think? Is that where this is headed? The data center, this will be the common way to get your work done in the cloud as well? Yeah?
Absolutely.
It will be cloudified.
Yeah, cloudified. There you go.
No, please.
Oh, yeah.
It's definitely the future. The data center is a must in this world. They exist already. And what we see is the need for these data centers to be more efficient, to be more capable of accessing the data, processing them, feeding them back, or give them to the public, to the internet or whatsoever. And that needs HPC calculation computing power. And the big providers are already in this development since years now. It's nothing new for them. They have seen this years ago and heavily invest. And what now emerges is the tip of the iceberg. The iceberg itself they have built for many years, but now the tip appears. And it's written HPC on it, but the data cloud is this time a huge iceberg underwater. So this definitely has to be. That is the future. What I wanted to add, maybe a step back to the machine that could also help these data centers a lot. It is a highly flexible machine because it permits for the first time that you have, as by the way here for Tianhe 3, this is from Mr. Wang, a presentation that you can fetch from the internet. You can handle a CPU-dominant workload. You can handle an accelerator, a booster-dominant workload, or accelerators only, CPUs only, and everything in between. And this is a fantastic presentation of what the modularity contributes to the art, because the in-between merges the 2 special qualities of CPU or GPU-driven processors, and that is what the modularity also brings about, a highly efficient, very flexible production system over many, many, many different application families, which I believe currently is not possible. Currently, these machines are designed to specialize on certain applications, like Summit in Oak Ridge is AI dominant, which is probably good, but that's all what it can. And we need machines, I believe, which can be much more flexible over a large area of possible applications.
Understand. Okay, well, great. Well, Hugo, can you wrap this up for us? What happens next, and what can we look forward to?
Well, what happens next, if you see that we are right now in the ETP for HPC working out the strategic research agenda. We do the same on the level of the RIAC, the Research and Innovation Advisory Board at the Euro HPC level, and we focus on certain topics highlighting system architecture. This is very new. We have a target to present it to Euro HPC in September for a decision by the governing board. The same is coming in from the ETP for HPC. So what we were missing in the past, to really have a close look to the system architecture, modularity, modular architecture is the European answer to system architecture. This is a priority topic right now, and we are working strong that this is in the view of the decision-making bodies when it comes to Exascale and beyond. You know that we see the modularity as a technology which started with an invention by Thomas Lippert, which was worked out on the European level, and now it is done in Jülich through Euro HPC procurements in Luxembourg and other sites. And ParTec was helping with the software, with a lot of technology developed to make it happen. And we believe that the next steps on the way to Exascale, but also beyond Exascale, will be to further develop all aspects of the modular supercomputing architecture as a European technology, not only for Europe, but for the world.
Well, thanks, Hugo. I think this is exciting. I really want to thank you guys for bringing me up to speed, and look forward to hearing more about this approach. So great job.
Thank you.
Thank you.
Giving us the opportunity.